gentlemen, go to joinpd.com. Here is the code you need. Determined quizzes usually quiz juicy pairs. So if you would put that in and you can get logged in, and then we can go from there, ladies and gentlemen. I will get attendance taken care of. Okay. All right, ladies and gentlemen. Basically, yesterday pushed us back a day from where we should be on our schedule, but we'll find a way. This trimester has more days than the first one anyway, so we should be okay with where we're going and what we've got to get done and all of that stuff anyway. But it does mean that your quiz that was going to be on Friday is now going to be your quiz next week, Tuesday. So, yes, great, excellent. Nothing like a quiz after a 3-day weekend.
Yep.
Yeah. So,
uber excited.
Uber excited, good. Uber. And then probably the week after that is when you'll be looking at your test for Unit 2, just so that you are aware of it. So, questions? Okay. Before we get into talking about classifying matter, which is what we're going to get to today, ladies and gentlemen, when we left the other day, we were talking about heating curves and looking at heating curves and interpreting information on them. So here we go, ladies and gentlemen, our first question of a day. Name me a region where the particles are increasing in velocity. Give me a region, A, B, C, D, or E, where the particles are increasing in velocity, please. All right. Brinley, which area?
A, C, and E.
Okay, A, C, and E. How do we know they're increasing in velocity in those areas, Cynthia? What's going up?
The line.
Correct. The line is going up. Because the line is going up, what else is going up, Rocio?
The velocity.
Okay, we said that though. And thank you. Temperature is going up. Okay? So temperature is going up, which we can see on the graph because that's what's on our y-axis. The line is going up, definitely. Okay? And the particles are moving faster. They're increasing velocity. By the way, because they increase their temperature and because their velocity goes up, their what also goes up? Their kinetic energy. All of those things are related. Kinetic energy is related to temperature. The only way you can make temperature go up is to make the particles move faster, thus increasing their velocity, increasing their kinetic energy, increasing their temperature. Very good, ladies and gentlemen. Okay? So in A, C, or E. All right? The region where boiling occurs. Which is the region where boiling occurs? A, B, C, D, or E, ladies and gentlemen. Please pick one. And there is only one. All right, Jen, where do you think boiling is occurring? Which area?
D.
Correct. Area D. Yes. Aaron.
Go to the LMC.
What's that?
Can I go to the LMC?
What is that?
This is my, this is,
And that happened Monday too, didn't it?
yeah.
Okay.
Or was it?
You do have to wait a couple minutes yet. I'm sorry, sir. Okay. As soon as the 10 minutes is up, yes, you can go ahead and go. In area D is where it is boiling. Now, what is boiling, ladies and gentlemen? Brenda, what is our definition of boiling? Going from what to what? Nope, not a solid to a liquid. Think of water on a stove. That's going to boil, right? What state of matter is it starting out in? Liquid ending as a gas, yes. Boiling is going from a liquid here in area C to a gas here in area E. Now we have to be careful because when we say water, what is the unique thing about water on our planet, ladies and gentlemen? It does, so do other gases. Anybody? Unique thing about water on the Earth's surface? It's in all three states of matter. It is actually in all three states of matter. Where is it a solid? In our poles, at the North and the South Pole. A liquid in the middle, right? The oceans, lakes, rivers, streams. Not the lakes, rivers, and streams. Maybe at this time of the year, they may be covered in ice. Liquid underneath, though, solid on top. And where is it a gas? In the clouds, not only in the clouds, but simply in the air that we breathe. There is water vapor in the air that we breathe. What do we call the water vapor in the air that we breathe, especially in summer? Humidity. Humidity, okay? Now, it could be misty, all of those things that they're not incorrect, but the term I was looking for was humidity. Is there humidity in the air in winter? There is, but not as much as in summer, which is why your lips get dry, your skin may get drier. People sometimes have an easier time getting nosebleeds. You also have an easier time building up a static electric charge, which can lead to you getting a shock, like when you touch a door handle and things. All of those things happen more in winter than in summer because there's less humidity or less water vapor in the air. But water is unique on our planet because it's in all three states all the time. All the time, okay? All right, yes, the short answer, D. That's where boiling occurs, okay? What three things are held constant in region B? What three things are held constant in region B? So give me three things that are not changing in region B right here, ladies and gentlemen. Hang on. What's that? You want me to show them?
I don't write anything.
Well, we're going to go through it in a second, okay? Okay, so first of all, before we answer this question, what is different about area B compared to areas A, C, and E?
It's stable,
What do you mean by that?
not changing.
Okay, the line isn't going up anymore. Okay, so good. Now be careful, because could we say that C is not changing? What's not changing in C? The slope of the line is not changing. I agree, but I understand what you're saying, and let's just be specific. In here, temperature is changing, energy is changing. However, the slope of the line is not changing. It's a constant. That's why it's a straight line. Well, this is technically a straight line as well, which means its slope is not changing either. However, this is a horizontal line. So, okay, what is one thing that is not changing in that area? What is one thing that is not changing in that area, Leaf? Temperature. Temperature is not changing. That is why the line is not going up. That is why the line is a plateau or flat or horizontal, however you want to say it. Daniela, because the temperature is not changing, what else is not changing? Think back to the first question we had when we said, what was the region in which something was increasing? And we said it could have been A, C, or E. Remember what that one was? Okay, can someone help her out? What's something else that's not increasing in area B? The temperature is not. What else? Kinetic energy is not. Kinetic energy is not. Otherwise, the temperature would have to be going up. What is the third thing that is not increasing in area B? The velocity of the particles. All three of those are connected, ladies and gentlemen. All three of those are connected. So yes, we were looking for the temperature. By the way, we could also say the mass of the particles, the kinetic energy, the velocity of the particles. Those are all things that are held constant in area B, okay? In region B. Questions? All right. What are three things that are changing in region C? Now in this area, what things are changing? Okay? And there may be about four or five things that are changing in that area. What? Okay, temperature is changing. We're starting out down here at around 40 some degrees. We're ending up here at around 120 some degrees. Temperature is definitely changing. If temperature is changing, Gerald, what else is going to change? Of the particles. The velocity of the particles is going to change as well. Nadia, what's something else that is going to change? We'll look at the graph. Just based on the graph, on the X and Y axis, what else is changing?
I would just have temperature. That's it.
Okay, that's the Y axis, correct? So if the Y axis is changing, if this line is going up, it also is going which way?
Energy is changing.
Thank you. Energy is also changing. Energy is also changing. Okay? What's one more thing that is changing in this area? We said temperature. Jared, what was yours again? I'm sorry. The velocity of the particles. The energy. What's another thing that is changing? If temperature is going up, this has to as well. The kinetic energy. The kinetic energy. Okay? So all of those things are changing. Energy, temperature, particle speed, particle energy, velocity of the particles. All of those things are changing, ladies and gentlemen. Good, 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 good. Name something that is held constant in area C other than the slope. Other than the slope, what is held constant in area C? What do you have?
The mass.
What?
The mass.
The mass of the particles and the temperature energy relationship as well. Now, I know that relates to slope, but the mass and the temperature energy relationship. In other words, for every so many kilojoules of energy you add, you go up a certain amount of temperature. Very good. Good, 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 good. Questions? That's it. That's all of it. All right, ladies and gentlemen. That takes care of that for today, ladies and gentlemen. If you would, open up your EISN and go to the classifying matter on slides 44, please. That's where we're going to start today. Slide number 44. Oh, wait a minute.
48.
Sorry, 48. Yeah, my numbers are wrong on the original slide. Sorry about that, ladies and gentlemen. Slide number 48. I hate it when that thing pops up and gets right in the way, ladies and gentlemen. Sorry, I have to reconnect the display. Okay, So what we are going to do, ladies and gentlemen, is we are going to classify matter. Please remember, matter was anything that has mass and volume. That is what matter is, okay? Now, there are two broad categories that we can put matter into, and then from there, we could take each one of these and subdivide them a little bit more. Yes, go. Yeah, please, sorry. Sorry. When it got to that time, please just go, okay? All right, so in this, ladies and gentlemen, when we classify matter, ladies and gentlemen, okay, when we classify matter, the two ways that we separate it are, number one, naturally, I just got onto another slide. A pure substance. Pure substance is when there is only one type of matter. One type of matter. Go ahead, sir, it's approved. Okay? Okay, so there is only one kind of matter there, one type of matter there. Now, there are two different kinds of substances, but a pure substance is there is only one kind of matter present in your sample. The second type is a mixture, which is two or more substances physically combined. So I'll let you finish typing that. Okay, so ladies and gentlemen, when we look at this, okay, one type of matter, we'll divide those up in a second. Mixture, two or more substances physically combined. When you physically combine things, ladies and gentlemen, that just means they're in the same place together, okay? They are just in the same place together. That is what a physical combination is. One thing being there with another does not affect that other thing, does not change that other thing. Okay? So that is what we mean when we say they are physically combined. Okay? Now, anybody know what the two categories of a pure substance are? What is the way to have only one type of matter?
Element.
What?
Element.
You could be an element, ladies and gentlemen. An element is only one type of matter, and it is actually a single type of atom. Here they are. These are them. Okay? So, when you have the element gold, all you have is gold atoms. When you have the element carbon, all you have is carbon atoms. When you have the element sodium, all you have is sodium atoms. Pure substance is only one type of matter. Now, when it's large enough that we can see it, we will normally refer to it as an element. If it is so tiny that we cannot see it, and the individual piece is called an atom, ladies and gentlemen. Okay? The individual piece is called an atom. So examples: carbon, oxygen, gold, silver, anything that's on the periodic table. Anything that is on our list of 118 elements on the periodic table, ladies and gentlemen. So you can have 118 examples of that, ladies and gentlemen.
Mr. Brand, was that one girl next to you? Is that your daughter?
What's that?
Was that girl next to you the other day your daughter?
Jayla Lisco?
I don't know.
Which side of me?
Right.
Your right or my right?
Yours.
Yes, that was my daughter. She wants to know why students are so mean to me after you walk by. She's like, how come your students are mean to you?
Has she
I
met
said-
you?
Only ever since she's been born.
Mm.
So, I said,
You should
that's just
understand.
Cynthia. She's mean to everybody.
She should understand.
That was funny.
What's it?
That was funny. I kind of figured. I was like, wait, was that his daughter?
Yep.
No.
You nailed it.
That was just
Just a random kid who I picked up and follows me around all over the place. Yeah. You know, that's like when people go, oh, is that a picture of you and your kids? No, they just came with the photograph. Or they just came with a picture frame.
Oh, you think you're so funny?
Put it on there.
Put my face out, put it in there. What?
You think you're so funny?
No, I just find it odd that we ask questions like that. There's a picture of you standing with a woman, and you know I'm married because I've said so before, and 2 children, and you're like, is that you and your family? No.
Well, it could probably be like your grandkids or like
My what?
your grandkids
Oh.
or something.
That's crazy.
You met my daughter, right?
That's crazy.
Yes, I met your daughter.
Whoa.
Do you think she's old enough to have children?
No.
Okay, then why would you suggest that I have
Well,
grandkids?
it's because you never know. What if you just had like someone?
I can't have grandkids. My kids can have kids. They then make me a grandparent. But
Exactly.
okay, we'll move on. Okay. Thank you. Thank you for sharing that
That was
moment.
insane.
Okay. Yeah, imagine how scary I would be as a grandpa. Yeah, that'd be bad. Okay, what is the other type of pure substance?
Compound.
Compound. Compound. And by the way, that is actually our definition of a pure substance, an element or a compound. If you were asked to define a pure substance, the definition is it's either an element or a compound, ladies and gentlemen. Okay? Now, you'll notice that a compound, the definition is very similar to what?
Mixture.
To mixture.
Huh.
To mixture. Okay? Now, only a couple words are different. I'll let you finish copying it and then we'll talk about those couple words. Okay. Compounds are made up of 2 or more elements off of the periodic table. Now, a lot of compounds, and when we get into naming compounds in the next unit, we're going to deal with a lot of compounds that are only 2 different elements in them. But there are some that have 3. There are some that could have 4. There are some that could have even more than that. Okay? So a compound is 2 or more of these things, these elements on the periodic table combined together. Now, some of the things on the periodic table don't make a lot of compounds. Some of them do. Okay? And they're chemically combined. Now, the difference between chemically combined and physically combined is actually fairly simple. When you chemically combine, you become something different. When you physically combine, you do not. Physical combinations are just things that are sitting next to each other. Chemical combination is when things actually react and form something new. Okay? So, for example, hydrogen gas is flammable. Okay? It will burn. Oxygen gas is needed for burning to support combustion. You cannot have a fire without oxygen. But if you put hydrogen gas, which burns, and oxygen gas, which helps it burns together, and they go through a chemical reaction, they make the thing that you put out a fire with. Water. They chemically change. They are no longer flammable. They are no longer needed to support combustion. They now can be put on a fire to actually put it out when they chemically combine. Okay? Now, examples are salt, water, sugar, baking soda. There are literally billions of examples of compounds out there, ladies and gentlemen. Okay? Literally billions of examples out there. Okay. Now, in terms of mixtures, there are 2 kinds of mixtures, ladies and gentlemen. Type number 1 is a homogeneous mixture, also known as a solution. What does the prefix homo mean?
Same.
Same. So it is a mixture in which 2 or more substances combine with a definite ratio. Okay? It is a mixture in which two or more substances combine with a definite ratio. Water, which is a what? Water is a compound. Okay? Cynthia has a bubbler. What is that?
Homogeneous mixture.
Okay, what kind of mixture?
Homogeneous.
Yes, because when she takes a drink of that, no matter where she takes the drink from, she gets the same thing no matter what. There's a definite ratio in there to all the crap that is in those things. Okay? Same thing with the Vita water here. Vita water? No, sparkling ice.
Sparkling ice.
There's no ice in there. How can it be sparkling?
It's just a company.
It's just
Not
the
that-
company? Okay. Anyway, also a homogeneous mixture, evenly spread out. Any type of solution, orange juice, coffee, soda, iced tea, homogeneous mixture. The air we're breathing is a homogeneous mixture. It is the same throughout. Doesn't matter if you're in the front of the room, in the back of the room, out in the hallway, outside. It is the same throughout, ladies and gentlemen. That is what a homogeneous mixture is. Then, ladies and gentlemen, there is what is example, soda, Kool-Aid, brass. A brass instrument is a homogeneous mixture. Those of you who are in the band, okay, and play a brass instrument, okay. I got to admit, the people in the band at the game the other night, the people in the band who play drums have it easy. They always bring a seat with them because they were all sitting on their drums. I don't know why. So what's the other type of mixture if it's not homogeneous? What's the opposite of homo? Hetero. Heterogeneous. Two or more substances combined in no definite ratio. Combined in no definite ratio, ladies and gentlemen. I'll go back to it. That, ladies and gentlemen, is a homogeneous mixture. I'm sorry, a heterogeneous mixture. Why?
It's the same ratio of nuts on in every single day.
Okay. Also, what's it?
You take them apart.
That's the other big thing. With the heterogeneous mixture, normally we could separate things because we could see the different pieces in it. We could separate things because we could see the different pieces in it. Okay? For example, when I eat this trail mix, I get rid of the almonds. Almonds are terrible. I throw them away. What? Okay. You should be around when I'm eating that then so I could give you the almonds.
Is it a cashew?
Okay? Cashews are awesome.
No.
Oh my gosh. How can you be wrong twice, Levi?
Isn't there a lot of mold on them?
What?
There's a lot of mold in cashews.
Mold?
Yeah, just like peanuts. What?
I've never had a
We all know
moldy.
peanuts are the best, though.
Yes, peanuts are. You finally got one right.
Something about them
That's
poisonous
disgusting.
or something?
What's it?
Something about them poisonous?
What?
It was like
Get your mind.
People can have very, very allergic reactions to things like nuts, things like that. But yes, normally like shellfish and peanuts, I think, are two of the things that if people are allergic to, they can have some of the most deadly reactions to. Okay? Point being, though, ladies and gentlemen, what you're looking at here is you're looking at a mixture of things and it is not evenly spread out. And that is our definition of a heterogeneous mixture. Two or more substances combined with no definite ratio. Other good examples, ladies and gentlemen, a supreme pizza. You can see the different toppings on a supreme pizza. Okay? You don't like a topping, pick it off. Salad is actually another good example. If you get a salad and it has something in there that you don't like, tomatoes or carrots, or they used to put this seaweed stuff on a salad at a restaurant we used to go to eat when I was a kid. That stuff got thrown out right away. Right away.
You can't throw out the dressing.
But
You can't take out the dressing, though.
you could eat around it.
That's just not eating the salad.
I understand that, but I'm saying because these things are not evenly spread out, you could work around the dressing if you wanted to. And if you don't want the dressing, ask for it on the side. Okay? The problem is you never know what you're going to get in a salad until it comes out to your plate. Okay? Depends on how good the restaurant is. Okay? Trail mix. By the way, even blood is actually a heterogeneous mixture. Different things in there that can be separated out. Okay? Questions? Okay. Cynthia's still typing, so we'll let her go. Almond. Good place for it.
What?
This is a science class.
Wow.
Shoot.
Okay.
Shoot.
I thought you weren't supposed to eat them, Mr. Brad.
Wait,
I'm not, but I'm making a point. I can pick out the things I don't want out of there.
That's just being a picky eater.
And you're not?
Huh?
You eat stuff you don't like?
Yeah.
Like
My
what?
mom makes it. I don't like spaghetti.
You can't even name something.
I don't.
Okay, here we go. So, filtration, distillation, crystallization, sublimation. Any idea what these are?
Looks like separation.
These actually, thank you, very good, Miro. These are ways of separating mixtures. These are ways of separating mixtures. So filtration is a technique that is used or uses a porous barrier to separate things in a liquid. So for example, if you have sand and water, you could separate them by putting them through a funnel, okay, with a piece of paper in it to separate the solids out of the liquids. Filtration, okay? Distillation is the separating of substances based on different boiling points. So for example, alcohol and water in a container, you could separate the alcohol because it will boil at about 78 degrees. The water will not boil till 100 degrees, so you can separate the two of them with this process. Crystallization is a separation, that technique that results in the formation of pure solid particles from a substance, from a solution containing the dissolved substance. Yeah, okay, great. Basically, you get stuff to make a solid in a solution and settle to the bottom. And sublimation is the process of separating substances when one solid will change to a vapor without melting, thus skipping the liquid state. Okay? Just wanted to give you some ways to separate them. By the way, that will not be on your test, so don't panic about that. Questions? Good.
Who won't be on the test? The vocab words?
Those vocab words, those methods of separation. Now, homogeneous, heterogeneous, element, compound, those will be. Okay, so which one would you say this is a picture of? Of those four, which one is this a picture of?
I don't know.
So what is this picture here representing? Now, first of all, people look at this and go, well, that's a compound, obviously, Mr. Brand, because that's a candy, and it's made up of sugar and carbon and hydrogen. That's not what I'm asking. If these are the pieces you were looking at, are all of these exactly the same?
No.
Then they can't be an element. Are they made up of two? Are there only two different kinds of things here put together?
No.
Which ones kind of represent a compound? The ones that have a filling, the ones with pink and white, the ones here that has the brown and white, those in this example would represent a compound. Two things put together into one, okay? So this is not an element, this is not a compound. Is this a homogeneous or a heterogeneous mixture? Why?
Because they are different.
Because you could separate them and they're not evenly spread out. You wouldn't grab a handful and get the same thing every time, and you will in a homogeneous mixture. Good. So this is representing a heterogeneous mixture. Good. All right. So what is this representing, ladies and gentlemen? This is no, not it is silicon. It's not representing it. That's what it is, which is an element. Okay, which is an element. Brindley, I will have to go get one. Okay. So this is the element silicon, ladies and gentlemen. All right. So take a look at this and tell me what you think this one represents.
Yeah, that's not very pretty.
Oh, what the heck?
I think
Rubik's
it's,
Cube gone wrong.
I think it's an element. That's Thomas.
Brindley, I do not. They are all gone back there.
No!
Yes, they are. You want to go look? Bang.
How are there eight
Bang.
and there's none?
There's 8.
Because there's 2 freshman classes right over there.
Stupid freshman.
Oh,
So,
I was one of them.
all right. So,
I mean, earlier.
what is this representing?
Shoot.
Picture.
Shoot.
Compound Y.
I guess I'll just
Because
go.
there's
Whatever.
different pieces.
What am I gonna do?
Different pieces stuck together. Okay? Different pieces stuck together into one thing. I would agree that is a compound, ladies and gentlemen. Excellent. Wonderful. Amazing.
Whoa.
How about here?
Sounds ugly.
I'm not asking you to judge how it looks. I'm asking you to tell me if it's an element, a compound,
Yeah.
homogeneous, or heterogeneous mixture.
This is nasty.
What is that?
Literally,
That's a rock.
it's literally Popeye's chicken.
That's real cool.
No, not a compound.
Heterogeneous mixture.
Why heterogeneous mixture?
Because there's different ratio of different things.
Okay. How do you know there's different things?
It's basically two different
One
colors.
is yellow.
The 2 different colors. One is yellow, one is kind of a brownish color, even a little bit of white flecks in there, or clear.
Yeah.
What?
Why would
I think that's flash.
I don't think so. I think those are different pieces that are in there.
could just say.
Nadia, what was your question? I'm sorry.
I don't think so. What?
One more time, a little bit louder without them laughing at each other in the front.
Why would it not be a compound?
The individual things that make it up are a compound, but because there's more than one type of compound here, that's what makes it a mixture. A compound would be the same thing throughout. A compound and an element almost look identical to each other, but a compound is made up of 2 or more elements. A compound would look the same throughout, though, because it's only one type of matter, okay? This, you could see the different things that are making it up. Like I said, the white, the yellow, the brown. So we would go with a heterogeneous mixture because they're not evenly distributed. Okay? Questions?
No.
Does that help? Okay. All right. How about here?
Compound.
Nope.
Is that like
Wouldn't it be?
is that like vegetable oil at the top?
Yeah, it's oil and water.
Okay, which is a
Oh
what?
my god.
Homogeneous mixture.
No,
Really?
heterogeneous mixture.
So that's
You
the
can separate
same throughout.
it. You can separate it.
Well, remember, you could separate a homogeneous mixture.
Yeah, but it's easier to separate.
Well, the thing about oil and water,
They don't mix.
it will separate itself. There will be an area of oil on the top and an area of water on the bottom. This is not evenly distributed. There is not oil and water all the way throughout here. We could see the 2 different things. The oil at the top, the water at the bottom. Even in here, you could see the oil particles. That, ladies and gentlemen, is a heterogeneous mixture, not evenly spread out.
I see something else in there.
What?
A fundamental photograph.
Yes. Okay, I stole it off the internet. Relax.
Whoa.
Okay.
You mean you didn't
They-
take these photos yourself?
You should have.
What the heck? How am I supposed to trust
That's
this?
like considered like
How am I
flagrant.
supposed to
Yeah,
trust
did
what
you
you're
credit
teaching?
these?
Yeah, I did it. The last slide that's hidden.
I can't trust you.
Uh-uh.
You mean
Well,
you didn't
if
take
it's
that
hidden,
picture?
then you
How is it
don't
credit
get
if
credit
it's
then.
hidden?
What?
It's not credited.
I said thank you. Doesn't that count?
No.
To who?
To
I
the
can't
internet.
trust this.
Okay.
You didn't take that. You didn't take that photo?
There's
You
no
didn't even
Emily.
get actual Coca-Cola.
Oh my god.
And why does it just
I said thank you to the internet for this picture too.
I can't believe this.
So what is this?
My whole life is a lie.
Soda.
Are we talking the can or are we talking?
Okay, great point. What are we talking about?
I'm
You
talking
tell
about-
me. Give me your answer and tell me what you're talking about.
I'm talking about the soda.
Stuff on the homogeneous.
Okay, the stuff on the inside, the soda in the can is a homogeneous mixture. But what would the entire picture be if you separated it? You could say it's a heterogeneous because the can is on the outside, the soda is on the inside. So again, remember when we were talking about kinetic and potential energy, be specific because someone could look at it one way, someone could look at it another. I was looking at this as a homogeneous mixture, ladies and gentlemen. Okay? Thank you, Internet. Good. Excellent. Wonderful. Thank you, Internet, again.
You could have taken a
What do
picture
those
of
say?
Coca-Cola.
This one says sodium chloride. This one says iron 3 chloride. This one says cupric sulfate. This one says potassium iodide, cobalt nitrate, and potassium manganate. So what are they?
Because you didn't take the picture.
They are all compounds, ladies and gentlemen. They are all compounds, all different compounds. How do you recognize them as compounds?
Because
They say
Take out the element away.
They have two elements in their names, thus those two things are combined into one. Good. All right. Whoops. Okay, stop there. All right. So, ladies and gentlemen, in Google Classroom, please go to it and open up the assignment that says classification of matter activity. So, in Google Classroom, there's an assignment that says classification of matter activity. Open it up.
You steal this from somebody.
Okay.
Let me
Up
guess.
at the top, ladies and gentlemen. What?
Let me guess. You stole this too.
Stole what?
This
This
entire
worksheet.
activity.
Yeah,
Let me
it's
guess.
Activity.
I made this one up myself.
Yeah, right.
Also, you stole it from your own mind.
I stole it from my
Oh.
own mind.
Didn't
Oh,
even
I
write it
see.
down.
But I gave myself credit because I always do.
Wow.
Okay, so up at the top here, ladies and gentlemen, I want you to write your four definitions. What it means to be an element, what it means to be a compound, what it means to be a homogeneous mixture, what it means to be a heterogeneous mixture. Take 3 minutes right now and get that done. Let's go. Okay, so here's what we got, ladies and gentlemen. In the back of the room, there are 8 stations. One is back there, 2, 3. The middle station, the far side, is station 4, 5, 6, 7, and 8. When you get to each station, you are going to look at the objects that are inside the weighing boat. And you are going to decide by looking at them, which of those 4 things are they trying to represent. So, just like our last one, Jim, your headphones should have been out a long time ago, but please take it out. Just like on the last one, don't go into it thinking literally, well, this is a plastic object, so it has to be a compound because it's made out of plastic. No. What do the objects in the container, which of these 4 are they trying to represent? Are they trying to represent an element, only one type of matter? Are they trying to represent a compound, 2 or more things chemically combined? Now again, in here, I cannot show you things that are chemically combined in the same way we can, but in that picture, which was that pointy like sphere thing with all those different colors in it, all those things were put together representing a compound. Okay? Is it a homogeneous mixture, a mixture that is evenly spread out? Or is it a heterogeneous mixture, a mixture that is all mixed up? Now, because some of these I'm trying to represent a homogeneous mixture, when you go to the station, please do not move the things inside the container around. Some of them are set so that there is supposed to be kind of a pattern to them to hopefully help you distinguish between homogeneous and heterogeneous. Okay? Now, in the bottom, you not only need to tell me which one it is, but why you think it is that. So the important part is not if you say it's a mixture, an element, a compound, or a homogeneous mixture, heterogeneous mixture, but what reasoning you're using to justify that. Maybe there's something there that I'm not seeing that you are that you could justify saying that this is a compound or that this is an element. Okay? Questions? Go to work. Go to work, go to work, go to work. Please remember, don't just tell me what it looks like. Tell me why you think it is what it is. Don't go that much into it. Okay? You are correct. But are they mixed or are they combined? And then look at each thing in here.
So it's a yeah.
Oh my God, is that
You ruined it.
Which one of those do you think is represented?
It's a
Why do you think it is that? Again, you might look at it one way, I might look at it another. As long as you justify your reasoning, I am fine with that. Some will be more obvious than others. You can go to any one you want after the one you're done. Please make sure you're putting your answers, though, in the right station number. Otherwise, when we go over them, you're going to be like, well, I can get that at that station. So remember, whatever station you're at, that's the one that you should be putting your answer down for. Most of you aren't starting at number one.
What is this in mine? Mine is still on.
Whoa.
Yeah. But there's like steel, aluminum.
And so, you know, I just walked around the house all of their own. She just comes over. So he's running the license for well, they have to fix that. They probably have more experience.
All these words we go from. No matter.
Nothing, but yeah.
How do you know? This and this, they all mean the same thing. They're all the same thing.
You just
If they wrote the same thing, they all have different
This is
definitions.
stupid. They're all the same thing. They're all the same thing.
Well, somebody messed them. Really, children? We had to go and take things apart and put them together differently to mess up the groups that were following you.
Guys. It wasn't me. Stop.
No, not you. It does not, because now I don't know which groups, when this happened, and which groups saw what they were supposed to see and which groups didn't. Remember, you are trying to describe what you think these represent.
There's a mix of
Okay.
things, but there's the same ratio throughout.
Okay.
So like in a house, you can have 2 cats and 42 dogs. That's a more heavily rated house because there's a different number. So all throughout the house, there's very a lot of dogs. So only 2 cats, so there's going to be like 2 rooms for the cat. But
I feel like I'm making this more confusing.
remember, like cats means they have 2 or more things. They're gonna walk around and things and you don't know where cats and dogs. It's not a home, it's the same.
Okay, but I'm not worried about that. What I'm worried about is how their whole things are represented. All exactly.
What do you mean they're not?
They're different things, but there's the same
That would
like
represent the one. Yes, that would represent an element. That's what we're going for. I'm not worried about if those are a mixture of ingredients making up that bowl. Those bowls overall represent one type of matter in there, and it's all the same.
At least the start of the rest of it, really.
Right here. Let's see the one I see.
I couldn't squeeze past.
I know.
I think someone in the other class was talking.
I don't know the first two. This is the first two.
So when you look at them, what do you see? Well, how many different kinds of things do you see? Well, you gotta see some of them. Are those all the same?
Okay, sure, yeah.
And that's what I wanted you to see. All of these are the same, right? How many different things are in there?
It depends if you're like very low.
If there's something in there, there's gotta at least be one thing in there, right? Is there more than one thing in there? Okay. Again, I'm just asking you the next question. Is there more than one thing in there though? No. There's just washing.
Liz hates it. I think Jack was fine though.
Okay. So what do we call it when you have all of the exact same type of thing in there and there's only one thing
He's
right?
like struggling.
I don't know.
Which of those
He's
ones?
doing fine, just hates the lefts.
Well, read the very first definition.
Read it out of basic trouble.
How do you make this matter?
Everyone else is struggling
So
with basic.
is there only one type of thing?
I just can't do it.
And that's representing an element.
I'm doing fine. I have an A. That's my highest grade.
Now, if there were two different things hooked together, but all of them are the same two things hooked together,
then that would represent the what?
Wait.
So if you had two things that were linked together somehow, okay? But in there, everything was that same two things linked together, like which one?
That one.
Right there? Okay, what would that be? What would that be? Because they're all, now, understand that a substance is only one type of thing.
Oh shit.
The difference is it made up of only one thing, or are there multiple things together making that up? That's the difference between an element and a mix and a compound. Okay? A mixture is just that there has to be at least two different things, not connected, just sitting in there together. Okay?
No, these are every single.
Yeah, you'll get to use them next trimester.
You don't even like this. When we speak, you're gonna like what we're doing.
Okay, next trimester.
Question is, will I fail this next like the project that I did for this university? I procrastinated to the last minute. I'm saying last minute as in I turned it at 11:50. I think I procrastinated. Maybe I'll ask you 10 o'clock. And then I still procrastinated to get started at 10:30. And so I have to do all my research and the putting together of the slides at 10:30 to 11:59. It's deeper.
No, wait, no, that's not.
Yeah, but I'm not sure she likes me. She liked my mom when she had her. She's been here 20 some odd years. I think she's like 26 now.
I see, exactly what I would have done. Which is if nothing else, start eliminating things that you know it can't be. And at least get it down to
She's been here a while.
I can still have it. I'm just getting a vibe. That's straight. Why did you ruin it? That's more?
Now, a lot of
Wait,
times,
was that 4 minutes?
because it's almost gonna sound like a definition. Alright, why is it an element? Well, there's only one type of thing there. Why is it a mixture? There's two or more different things there. Why would the mixture be homogeneous? It's for an element. Okay? So don't worry if it sounds like the definition, because it should actually sound like the definition.
This is so cute.
She likes the Legos. She also likes those. She likes those ones.
Yeah, I like the. I don't. Do I want to take this?
It's not even that bad.
Sure.
Sure. Okay.
I mean, it is not bad.
This is inappropriate for school. Can't have this.
Why is there stuff on the table?
Did it look like that when you got there?
There's a whole.
Is there a problem, like, mine made a new
Okay, because this is the way it was originally.
See, there's like a lot of lines.
Yes, this is the way it should look.
That you can.
Well, okay, first
Why
of all,
did you kick me?
Oops.
is that?
Sorry, I
tell me
tripped.
what you said.
So you just fucking kick them all.
No, I didn't. How did I do that?
Cause you stopped and you kicked me.
I did that. That's not what
And then I
happened.
said, why did you kick me? And you went, oops.
What happened? You're psycho.
Spread
How
out.
does that go? 'Cause you said-
Okay. Then that makes it a.
Glad we're on the same page.
Very good. Fine.
Where do you go? Sorry.
Yellow and blue.
Sorry.
Brenda, did you
I thought the yellow was exciting.
I actually have a charger in my backpack.
Why aren't you charging that?
Look around. Is
All
there
I
an
have
outlet
is
near
red
me?
green on.
No. I will not fit. I will not reach.
They're underestimating the
No, you can't.
I know it won't reach as far. I'm not stupid. Okay.
Right, but then will they be evenly spread out?
I just put the ratios. Whoa!
Whoa.
Whoa.
What the heck? You just punched me. Punched me. With like the fury of 1,000 men. You just punched me.
But what about like when
What the heck?
What about like when you kicked me?
The fury of
That was nothing
1,000
like, because
men.
that was an accident. This was not an accident.
How did you accidentally kick somebody?
I was walking and then I tripped. And he's all psycho and he's like, you kicked me on purpose and that's not what happened.
All right, ladies and gentlemen, so let's take a look at these. Now, again, you and I may disagree on what it represents, but as long as you can justify what you're saying, that is the most important thing. So again, I look at him and I see him one way because I was setting him up to be that way. You may look at it and say, well, couldn't it be this because of this reason? And as long as your reasoning is sound, we will go with it. So down here, ladies and gentlemen, I got pictures of them. At Station 1, what do you think we were trying to represent at Station 1, Nadia? What'd you put down? Okay, why? Okay, and all of the things in there are the what? Thank you. That is the definition of a compound. You got exactly what I was going for there. Each one is a green block with 2 white blocks. They are all linked together the exact same way. Now, that doesn't mean that's the only answer, Jerry. I see you kind of looking at it like maybe you had something different. What did you have?
Homogeneous mixture because the ratio was definite.
Okay, the ratio is definite, but how many different things are in here? See, I would say 1 because these things are hooked together. So these things are representing one thing. That's the only reason I wouldn't go with a homogeneous mixture here. A mixture needs to be 2 different things in there that are not combined. And in this case, it's hard to tell that I'm trying to represent chemically by actually putting them together. Again, as long as your reasoning is sound, we could go with more than one answer. All right. How about Station 2 here? How about Station 2? Jacqueline, what did you guys put for Station 2? Or what did you put for Station 2? Okay. Heterogeneous mixture? Why? Okay, and that is exactly what I was trying to show you here. I'm glad you actually got it. These are all different kinds of nuts, ladies and gentlemen, but they're different. So these are different from these, which are different from these. And they just happen to be randomly spread out out there. There's no pattern to them, anything like that. I was going for a heterogeneous mixture with that one. Very good, ladies and gentlemen. I got one that you actually got then. Did anybody see anything else here?
No.
All right, how about Station 3? Rocio, what do you think Station 3 was? Good, why? They're all the same, and there's only one kind of thing here. Now, again, I heard people talking, going, well, what is that actually made of? Is it made up of iron and something else? You're getting more intense than I wanted you to. There's all one type of thing in here, only one type of thing. I was shooting for you to say that it was an element. All right, how about Station 4? How about Station 4? Leaf, what are you thinking?
Heterogeneous.
Why?
Because if you were to grab like one row, it would all be the same. Like for the next row, you'd get the same.
Okay, but that actually makes it what then?
Homogeneous.
Homogeneous.
That's
If
what I
you're
meant to say.
If you're going to always get the same thing, and homogeneous is hard to represent here. But how do you know these things are different? They're different by colors, and this one has two things put together. So these would represent compounds. These would represent what? Elements. Okay? So it's a mixture of different things here. I tried to put them so that the pattern would kind of repeat itself. Definite ratio, 1 yellow to 1 blue to 1 of the red and green compounds. So you have a definite ratio here. If nothing else, that represents a homogeneous mixture. Good. All right, station 5, ladies and gentlemen. All those things together. Levi. I was trying to represent a heterogeneous mixture here. All different things in here. Some of them are like hooked together like compounds. Some of them are just plain and simple, just pieces like elements, but there are all different things here. How about station 6? What did you get for that one, Jin? So what do you got for it? Absolutely. They're all the same type of thing in there. Trying to represent an element, ladies and gentlemen. Only one kind of thing as well. Okay? All right. Station 7. What did you think, Cynthia? But are these things put together?
Oh, no.
So, I'm sorry. Remember, I'm looking at this one over here.
Okay.
So what did you think this one was representing? Well, what do you now think it represents now that I told you it wasn't a compound?
Homogeneous mixture?
Okay, very good. Again, a homogeneous mixture. The idea that there's two different things here, right? And that they're kind of evenly spread out. A definite ratio, though, okay? A definite ratio of a certain number of these to a certain number of these. Trying to represent that homogeneous mixture. All right, so what would 8 be then? Now again, you might have put more than one thing down here, but what do we have for number 8? Daniela, what do you have for it? You had a compound. That is what I was going for. That is what I was trying to show you. Trying to show you that each of these things is the same because they all contain a bolt, a nut, and 2 washers. So they all have the same things in them. And there's all the same combinations in here. I was trying to represent a compound with that, ladies and gentlemen. Very good. Questions? All right. All right. Great way to end the day, ladies and gentlemen. Perfect.